So I'm now on a different machine that already has the software installed. So I'm going to show you a little bit how this works while the other machine is still installing. So if I go to the Wolfram CDF player here, right? I have these in my recent files because I've already opened them, but you probably don't, right? So you probably have that first one, Robot Manipulator Workspaces, already in your downloads from clicking the link in the previous video. So if I click this, you might get something like this. It likes to do this the first time I run it after restarting the machine. If I just close it and I reopen it, it seems to work just fine. There we go. I'm not sure why it does that. I don't know if it's just our machines here, but that's what it does. So there's some information down here, some details about this particular program, some links from the creator and the citation, right? So here's a citation for that itself. We can increase the size that it's loading, right? So 125 or 150, and then we can start to play with this. This is not just a document, but it's an actual interactive application simulation sort of thing. So I can click and hold down and I can rotate this around, right? And we can see here, this particular arm has 3 revolute joints, right? So 1, 2, 3, and they are displayed as these cylindrical forms, right? So we know the actual robotic arm wouldn't look like this, right? This is just the way that it's rendered to make it clear what exactly is going on. Now these over here control these joints. These up here are the angle, and this is the range that it's allowed to work within. So if I slide this all the way over this way, that is right here on the total possible range, and if I slide it all the way over this way, that is there, right? If I increase the maximum allowed range, that will increase the amount it can spin, right? It's still all the way over to the left, all the way over to the right, but the range here will increase that, right? So that's kind of how it works. So these types of motors, they don't make complete rotations like the wheeled robotics we were using last semester. Instead, they're highly accurate, but they don't have a full 360 range. So even if I increase this all the way to the maximum, we should see, there it is, a little gap in the workspace there. So that little gap there, that's because we don't actually have a full 360 degrees motor, right? So there's that little gap there. So as we move these around, we can see how it affects the workspace, right? So that's pretty cool. So this is moving within that workspace, right? Right now these don't do anything because, well, there's a little bit of range there, but they basically don't do anything because of how limited I've made that range. If we increase the range, you can see how it affects the workspace, right? So this is a pretty cool little simulation. Now, in addition to this robotic arm, there are other robotic arms in here as well, right? So I mentioned already that this robotic arm has these 3 revolute joints, right? Not all of them are that way. If we bring this down, we can see other types of arms. So we are essentially using the elbow right now. This planar robot is also 3 revolute joints, but this is a 2-dimensional robotic arm with a 2-dimensional workspace, or rather it's a robotic arm with a 2-dimensional workspace because all of these revolute joints are on the same plane, right? All of them move only horizontally, none of them vertically. So if we jump back to the elbow robot, you can see we have 1 horizontal and 2 verticals, and that's why we have this 3-dimensional workspace, right? So left, right, up, down. But there's also a little bit here. So if we increase, nope, not that one. This one, no. Maybe we have to do a little bit more. There we go. So you can see here, as I increase that, this workspace not only has up, down, left, right, but it also has some thickness to it, right? When we go to this planar robot here, it's got left and right, and it has depth, but it has no up and down, right? So that's why it's a 2-dimensional workspace. Now, depending on what we do at the range, we can make this into a 1-dimensional workspace, right? So if we shrink the range on 2 of them down, right? Now we essentially have a one-dimensional workspace, right? It doesn't really have any depth and it has no height. So I mean there's a little bit of depth because I can't perfectly make those zeros, but you get the idea. So you can check out some of these and play with some of these. Another one to note is, let's see, the CNC robot. So this one, if we look on here, it has no revolute joints, right? So it just has these prismatic joints. So if I give these a little bit of range, instead of having the one maxed out and the rest not, you can start to see sort of what this actually looks like. So, oh, how do we have it? There we go. It's a little wonky. Let's try to get this looking right. There we go. Something sort of like that, right? We have 3 prismatic joints, and each one moves along a single axis. And so we get this more cubic workspace, right? So it's not like the other one where we had a circular workspace. Now we have a cubed workspace. And if we limit these as well, you can see sort of how its one-dimensional workspace would look as well. In that situation, you just have a straight line that it can move along, right? So if we take this top one, right? So in this situation, it moves just up and down along that line, right? So that's how this would be one-dimensional. We add one of these also in here. Now we have a 2-dimensional workspace, right? Up, down, left, right. And then if we add a little bit of range to this other one, now we have a 3-dimensional cubic workspace. So that's essentially how this projects file works. Now if we go back to the internet, right, and look at some of the other ones, we've got like common robotic arm configurations here. And this one's kind of cool, and we can save it and open it. Would you do the thing? Okay. We can open this one. And it's very similar to the previous one, but it has more joints. Everything in the previous one had, I think, just 3 joints, whereas here we can see this one has 6, right? And it's got the gripper. So actually that's 7 different joints here. Each one of these joints represents a degree of freedom. So we've got the one at the base, we've got these, this one, right? But we can't see the workspace in this situation. We can only see the robot itself, right? And we can't limit the range either, right? So all of these have a full 360 degrees possibility, right? Now this joint here is a little interesting. Because there's actually 2 joints. Oh, wait, yeah. 2 joints that make this up, right? There's this one here that rotates along that, and there's this one here that rotates the gripper, and you've got this one here that rotates the whole thing, right? So we've got several degrees of freedom, all sort of right around here. With an actual robotic arm, that might all be represented as sort of one joint, or the way that we might think of it might be just like a ball and socket joint, but it has multiple degrees of freedom anyway, because you would have to know the placement of multiple numbers to be able to put the robotic arm exactly in that position. And that's essentially the idea of degrees of freedom. It has to do with knowing exactly where to place each joint to get the robotic arm to have a very specific position, right? So if I wanted to pick up something that was right here, right, I would need to decide what degree each of these joints would be at, and that means that each one of those is a degree of freedom needed to know, right, to be able to put this in this exact place. Now there might be multiple different arrangements that might do that, especially in a robotic arm that has this many joints, but if you're looking at some of the ones that only had like 3 joints, right, any specific point that this can reach, you'll probably have to have a very specific value in these, right? Now you also have this little button here, which hides or shows the robotic arm, which I'm not sure why you'd want to get rid of it altogether. Well, I've got some ideas for why you might want to. But yeah, so that's that. There is another one in here I would like to show you. So if I go back and we go to parameters for a 3-link robot, this one is kind of neat too, but it does have a few little issues, right? So on this one, you can specify whether you want to be a revolute joint or a prismatic joint for each one. So that's fairly cool. The only issue that I have with it is it still lets you sort of control it either way, right? So this controls the revolution, right? The degree around this robot that this revolute joint is creating, causing, whatever. If I switch it to prismatic and I move this, it's still actually revolving around that motor as if it was still a revolute joint, right? So that's something to be aware of. Instead, you kind of have to know that these parameters here don't change depending on which you choose. This only changes the graphic. So other ones along here will do what you need it to for like prismatic. And you can also sort of add like extra arms to it and the rotational property, right? So these are sort of like the specific settings that you want for this, right? But only one of these would actually apply to the specific joint itself. So like in this situation, if this were a prismatic joint, these 3 here should be constants, and this should be the only thing that this joint would be able to control. If I had a revolute joint, these 3 should be constant, and this should be the only one that that joint would be able to control. So it is what it is. It's still a pretty cool little simulation. You just have to be aware of that specific sort of aspect to this simulation. And there are some other cool ones on here that you can check out as well. And all of these should be openable using this Wolfram CDF player.